Is my screen visible?
Ha, sir, it is visible, sir.
So today presentation will consider correlation and regression analysis and some practical knowledge on our software and some practice we will do there. So as already I think all of us briefly have some prior knowledge about the correlation and regression. So I will not just focus on the theory part. I will just focus on the more time to the practical applications. So before that, just go through the PPT. So what are the goals? So we can say that we have to understand the correlation and regression. What are the coefficients we have to use? Which kind of associations we have to measure there? Okay. So different correlation coefficients are there for to check the collinearity for categorical data, or you can say the continuous data. So as we know, the correlation is what? Correlation is nothing but the you have to check the association of two variables, two or more variables. So linear means that is a linear association between two variables. If you are in changing in one variable, that is also change in another respective variable, or either it may be increasing or decreasing. So some kind of association it will show to you. But when in regression, we will discuss later also. Regression, we have to just find the value based on the dependent variable based on the some response variable based on some independent variables. So basically, we have to check here the correlation between like if you are getting the height, so obviously the weight will also increase. If you are temperature is high, so pulse rate will also get the increase. If you the age are increasing of any person, then the weight will also increase. So age and height that will also be correlated. Amount of fertilizer if you are using in crop in some crops, so it will definitely will be the increase in the crop productions. So if you have the house size, it will be small, so electricity will be small, otherwise will be large. So these kind of variables we have to study where they may be related, but how much they are related we have to check with the some coefficient or some graphs by using graphs. So scatter diagram is one of the field, you can say, the graph or plot that where you can check the relationship between two variables. Okay. In the correlation, there is no dependent or independent variable such as either you can find the correlation of x and y, either you find correlation of y on x, y and x. So both are will be same. So for example, this example we have also considered for the numerical purpose in R and here also. So just we have taken the scatter diagram of this. Just this is just scatter diagram. This is just a plot. Okay, of the science students and the science test and statistics test of some 10 students we have taken here, and the plot with generated here. So different kind of plots will be there. So basically the correlation we have just written, but this is are the type of the correlations we can say, or the scatter diagram. So correlation may be different type. It may be positive related or negative related, or there may be no correlation at all. So as you will see here, the first paragraph, this one, in this, you will see R equals to 1. R is the coefficient of correlation coefficient. So where it shows the perfect correlation means when you have the draw this line and all the points are near about to each other. It means and they are showing some kind of trend from lower left corner to the top right corner. In the second one, you will see here some points are deviated from each other, or you can say the straight line. So this will be not perfect correlation, but the positive correlation is there. Somehow it will be moderate kind of correlation, weak positive correlation we can say. And this is there is no perfect you can say there is no perfect trend. If you are not getting any trend here, then it will be zero correlation or no correlation. Similarly, you have to find the pattern of the negative correlation, that is top left corner to the bottom to the right. So it will be moderate type of correlation. This is strong positive negative correlation, and this is perfect negative correlation. So basically, range of correlation coefficient lies between -1 to 1. Everyone knows. So basically, we can say that the correlation is nothing but the that having some giving some strength or direction of association between two variables. While the regression, when we have to fit the model to the predict independent variable from one variable to the independent variable. So there are some assumptions we will thoroughly I'll discuss here. That is the variables that you have used here that may be independent. they are linear related. Observations are coming from the normal population, or error term, normal residual means error. So error term will be normal distributed. Homoscedasticity means the variance of the parameters, or the whatever the parameter you are taking there, that will be having the constant variance. So for the qualitative type of data, you have to find the correlation by using the Spearman or Kendall. So in this PPT, I just taken the Spearman correlation, that is rho. We will discuss it later. So basically, the difference you will see here, the basic difference, the meaning, this kind of association can be defined by the correlation. But when you have to describe any kind of means, you have to predict the value of dependent variable based on the independent variable, that will be considered under the regression model. So both dependent and independent variables. So in correlation, there is no difference in the variables. Both are maybe dependent, or both are maybe the independent. So in both variance may be different in the regression analysis, as we can say they first maybe one may be the dependent, other may be the independent variable. So it describes basically only for the linear correlation between two variables, and that is also for the linear regression between two or more variables. That is, if you are taking the multiple variables or independent variables, that will also be the linear. Multiple regression model, we can say, multiple correlation, we can say that. So these are the basically the differences here. Just one second. हम्म,
कब तक आओगे?
अभी लेक्चर है साथ में।
ठीक।
So sorry for the disturbance. So these are the assumptions we have already discussed briefly, and the same we have just mentioned here throughout. So the correlation, that is in statistics we are using there, that is the correlation coefficient that shows the degree and distance between two variables of the dependence or independence of the variables. So Pearson correlation coefficient, that is given by Carl Pearson, Spearman correlation coefficient, that is rho, given by the same Carl Pearson coefficient of correlation. So this study is showing the degree and distance between two variables, where that will be called as a product moment correlation, you can call it as. It measures the nature and strength between two variables of the qualitative type. If the sign is positive, it means there
Good
is a
evening,
positive.
sir. Sorry
Yes.
to interrupt. Your voice is too low. We can't able to hear properly, sir.
Okay, okay. Let me speak loud. Yeah. So it measures the nature and strength between two variables of the qualitative type. If the sign is positive, it means the relation is direct. It means when you are changing in one variable, that will also change in the another variable in the same direction. Means if one is increasing, then other will also be increasing. But if the relation between them is negative, or negative correlation, you can say that, it means when one variable is increasing, the change in the other one will be the decreasing, or vice versa. So the this value R correlation coefficient lies between -1 to 1. So here, this is not perfect, but we can say that the zero correlation means there is no correlation, or these are the R values. When you are getting -1 and +1, this is the range basically. If you are getting perfectly 1 and 1, so it is perfect correlation. Either it may be negative, or either it may be positive. If it is larger from 0.7075, something like that, up to 1, so it will be strong. Otherwise, it will be moderate or weak correlation there. So everyone knows the correlation coefficient will be calculated by using the formula, that is covariance of x and y, and this is sigma x and sigma y. This is nothing but the, if you will multiply 1 by n here, sorry, small n we have taken. So this is 1 by n here also. So this is also 1 by n. So this is nothing but the variance of y square, and this is variance of x square, and this is the covariance one. So directly we have written this. So this n will be cancelled out. That's why we have just not mentioned there. So this is the correlation coefficient that we have to find the measure of relationship by using this formula. For the rank correlation coefficient, this is some time of we have some face some situation like a simple correlation coefficient is based on the magnitude of the variable. But in many situations, it is not possible to find the magnitude of the variable at all. In that case, we can use different method of check the correlation. That is the rank correlation. That is basically based on the rank of the variable. Okay. So it may be defined like you have to check the mental level. Okay, so mental level means IQ you have to check. So IQ you have to order them. This is the first person. This is order one. The second person. This is the highest rank. Second order. So some order you have to define to the variables numbers. This is the formula basically in case of no ties. No ties means if you are getting the same values like repeating values is there. So you have to mention them the same rank to those are getting the repeat number. And that will be, this formula will be changed in this case. It will be summation n into n square minus 1 and divided by 12 in the bracket. Okay, so this change will be there in case of no ties. So we have just taken here the simple case, then we have no ties here. So the method, what is the method, the procedure we have to follow to calculate the row for correlation coefficient or rank correlation coefficient. This is the x values you have here. X means statistics or science. Y you can take either x or y or y or x as your wish. So basically, first of all, you have to arrange the number. Then you have to find the largest number and put them rank 1. Then accordingly, you have to put the rank 1 to 10. Okay, those 10 data we have here. So same method you have to apply for the other variable, that you have to find the maximum number here and put the rank 1. If there are some repeated numbers like 21 is repeating in the same variable, in that case, whatever the number is repeated is there, so you have to assign them rank, same rank by taking the average of 2. Means if you are finding the rank and 1, 2, and 3 position, there are two numbers like 21 and 21 at for 3 and 4 position. So you have to take the average of 3 and 4. Okay, and you have to assign the rank, that is 3.5 to both of these numbers, and the next rank will be again it will be 5. So in that case, the formula that I have just mentioned you, that will be changed, and these how many times the number is repeated, the formula will be, you have to change that time also. So by using the formula as you have seen here, this is according whatever the your requirement. You have to create your variable. So you have to find the deviation from xi to the mean, yi to the mean of y values and their variances. So in that case, you have to just calculate. We have just mentioned here x students and y sciences. So x minus x bar, all the parameters we have just taken here and calculated. So these are the sums. So total we can say here sum of the xi minus x bar square, sum of y minus y bar square, and sum of these covariance term you can say sum of x minus x bar, y minus y bar. So the formula again we have written here. The whatever the value you got from the table, you have to just mention or you have to just put in this formula R, and you will get after calculation. This is here. You will see this is 0.76. So it is, you can see the strong correlation between the statistics and science student means when you have to check the score, those are getting higher marks in the statistics test, they will get also the higher marks in the science test. Okay, or the vice versa, you can interpret this one. So some other methods, not the method, we can say some other formulas that earlier method we have taken there, the that is also simplified one method. Correlation coefficient formula is same, just we have multiplied this x and y both, and after some simplification we have just modified this one. If someone is using this kind of formula, then for them also we have just taken the values here, x and y, xy multiplied, because xy sum of xy is required there, sum of x, sum of y, sum of y square, sum of x square. So all the values, all the variables we have to create here, and after calculating these, we have to calculate the sum of these values. Then we have to put all these values in this formula. So you will get the required answer. So answer is, because the formula is same, just representation different. So formula you have just used here, this will also provide you the same answer. That is 0.76. Okay. All of you are getting? Please
Yes.
respond. Okay.
Yes.
So the same question, we have just not changed the questions. So either we may change the questions. So just we have taken the same example, and based on this we have just put the rank. Either we have to take some category data and then put the rank to them. Just for showcase purpose, we have just taken the same example. And what we have to do, we have just first taking the students statistics and science test scores, of 10 students, and we have to provide the rank. Either you can arrange them, either whatever the position are there, just find which is the larger number. So in the first statistics one, this is the larger one. So you have to put the rank 1. Again, which is the larger number you have to find here. So this is 23. So again, you have to put the rank 2. So as there is no repeated number here, so rank will be indivisible. If there are repeated numbers, then the rank will be assigned to the 2 or whatever the numbers are repeated to the same rank to them. Similarly, you have to follow the procedure for the science scores. It means whatever the larger number, you have to provide the rank 1, that is 26, then 20, which one is 24, then 23, something like that, 25. So you have to accordingly provide the rank. Then what you have to do? Then you have to take the differences, means differences of the ranks. Okay. So rank of the statistics, ranks of the sciences course. So you have to take the modulus difference. Either it may be larger or either it may be larger. So you have to modulus difference. You will take all the value will be positive. Then you can take the square quantity di square. So after this, you have to take the sum of di square as the formula requires 6 summation di square. So you have to calculate 6 summation d square. So d square is 48, and n is the number of observation, that is 10. Okay, just put the values here, you will get the answer, that is 0.709. So this is again, you can see the strong type of correlation. Again, it will also providing that whoever the students are getting higher marks in statistics, they will also get the higher marks in science test. Okay, so this is the interpretation we can say. And for the R code, I will just first explain the basic R code here. Then we will go to the R window. Then we will perform the exercise there. Just for the your visual interpretation that I can explain here, you can use. You can see which formula is working, how it will be the function work there. So you will see here, this is the statistics and sciences. So I already observed that the this is the third day. So you already have some basic idea of R. You already know earlier that also. So just this is the method that we have to assign the values. If you are assigning some value to variables, like this is something X or Y. Okay, you can either assign single values. If you have more than one values, then you have to combine them by using the character C. This is the method, or this is the vector, you can say. This is the string of vector. We have saved these values to the statistics, and we have saved these values to the science. Then we have to perform the correlation. Correlation between which? Between correlations, statistics and sciences. And by which method you have to perform? The method we have mentioned here, that is the Pearson. Okay. So there are some other methods also. When you will type the help in R, so when you will type help and core, means this command. So it will provide you the syntax of the R code, that how this command will perform. So this is the method you have to define here, which statistic you have to find basically. So the correlation command, this is the core command that is used for finding the correlation between two variables, linear correlations. So when you will put the values, it will provide you the direct answer. Whatever the just these calculations we have done, this is the numerical method. So just by using the single command, it will provide you the same answer. So for the rank correlation, again, Spearman rank correlation you are finding, but for the ranks. So Spearman rank test, you have to prove using this correlation dot test between the statistics and science method is Spearman. So it will provide you the again Spearman row values. So the test value, when you will see, the test value will be provide you statistics 48. That is the answer, sum of di square, and p value is 0.25. P value means you have to compare the p value with the level of significance. If your p value level of significance, suppose approximately we always take 5%. 5% means this is 0.05. Okay, so we have to compare this value. If you are taking 1% to 10%, that is usually everyone takes. So we just suppose that we have taken 5% level of significance, that is basically alpha. So we have to compare this value, p value, with this. If this is less than 1, so we will not reject the hypothesis, whatever the we have taken. So we can say that whatever the values we have taken, this is the coefficient value. It is the showing the perfect correlation. Okay. So if you have to find these are the direct command basically. If you have to find the manual method, whatever the tables we have created there, if you want to create the tables here as well, means you have to find sum of square, that is x minus x bar whole square, y minus y bar whole square, multiplication of the x minus x bar and y minus y bar, then you can perform it manually. So here you will see that we have just created x bar, whatever the value we have taken, n is the length. Length means when you have to take the length of any number, that will provide you the how many number in any character in any vector that we have defined in R. So in statistics there are 10 numbers, so it will provide you 10 results. When you have to find the mean of the statistics scores, then you have to just use the command mean. Okay. Then you have to find the mean of the signs that you can use by symbol y. Means these are the variables in which you have stored the value, and these are the commands that is you are performing. Okay. All of these. So basically, these are, we can say, these are the characters or the vectors where you have to store the calculated value, and these are the commands that you have given to the R that calculate the mean, calculate the sum of statistics means x minus x bar whole square, x minus x bar whole square, and take the sum of this. This is the simple meaning of this. And same y minus y bar, and this is covariance term, you can say. Then R manually, that is nothing but we can say this is the covariance of x and y, taking the x and y divided by the square root of sigma x and sigma y. This is the simple formula here. So after the list command we have used here to mention the all the result directly at the same time. So it will be your results here. So for the Spearman ring correlation, this is another method you can use here. Sum of x, y. This is the sum we have taken here. Then you have to take the divided by the number of observations. Okay. So again, this will provide you the second method that you, if you remember, we have used the second formula, sum of x, y minus x, so summation of summation y divided by n. So that formula we have also created here, and that one also will provide you the same value. This is for you exercise if you want to perform the exercise. So for the regression purpose, this is up to the correlation. We have just seen the simple correlation here. Okay. And their calculation, their R code. Now for the regression. Regression means, as we have already discussed, means this is also the association, but here you have find some numerical values that is predicted, you can see. Okay. So how much a independent variable is related to the dependent variable means if you are changing in x independent variable, so how much change will
Hello,
affect?
sir. Hello.
Yes, yes, yes.
Sorry for interruption, sir. Actually, I want to ask one question. Just like for correlation, you said two, three method. So I had doubts, sir. Just like in first one, there you discuss about like statistic and then person and there one thing also you told, and after that that ring correlation we run. So, sir, first one there you so that is the packaged one, na? We will use something package, so we can be run our R code. And another one, what you saw, that is the manually we will feed, and then we will run, na? I'm
Yes, yes,
correct
yes.
or
Yes, you are correct. Basically, there are different methods. R
yeah,
is a software, okay, or calculator
yeah,
in which you have to put the commands.
okay,
But you know what you have to get the output. So it whatever the things you will do, it will provide you something. But
yeah,
it will be helpful to you or not. So that you have to know about if you want to go through these different commands like how to plot the data or different type of commands are there. If like normal distribution is there. So if you have to use the syntax or you want to calculate the probabilities through normal distribution, so what the command we have to use there? Because first we know the command. Either one method is there that you go to the console window or and that there is a manual PDF. Okay,
yeah,
either you download some PDF also. There you will get some short commands which are used in R. Okay, so before that you have to remember. So this is the correlation command that you directly can find the values. But
Yes.
before that, you know the syntax, how it will work. If you will put the just value here, x and y, it will provide you something. But which method it has used? Generally, it takes Pearson method, called Pearson method. But sometimes, suppose that you have to find the correlation by some other method. Okay, so you have to mention in the method basically. So
Ye-
before applying the command, you know the syntax of the command.
Oh, yes, yes, yes. And before that, I want to be arranged data like that.
Yeah, means like I just this is the small data I have just copied. I just write it by hand. Okay, if you
Mm.
have the large data, big data, if you are working on big data, so what you will do, either you have to have some CSV file or Excel file, you have to import that. Okay, either you have to use some other package. There in R also there are some packages that having several data. I will also show you. Okay, so before that, just this is the direct command method, and this is manually. Means
Yes,
what the method you have used by using the pen paper method, the same command you can apply here.
sir.
Okay, this is
Yes,
for practice basically.
yes, sir.
Yes, ma'am.
Okay,
As
sir.
we when you will use the command variance of x. Okay, this is the just difference I am saying you. So it will variance of x will provide you the biased variance. But if you have to find the unbiased variance, then you have to multiply n by n upon n minus one there. Okay, so you know the syntax, then you can apply. Otherwise, it will give you the robust result. Means raw result you it will provide you. It is correct or not, you have to define this. Okay,
Yes, yes, yes.
let me go further.
Oh, yeah. Thank you, sir.
So in regression, basically, we have to find the dependent value or predict the dependent variables value on behalf of independent variables. So these may be different. Either it may be x1, x2, or something like that. That is multiple regression. Okay, it may be simple regression, but both are the linear one. If you have to find some non-linear method or some other methods, then you have to use some other method like GLM, where it have used to some transformation method to convert them into linear one. Okay, so this is already we have discussed. So basically, this is the flow chart. You can take the screenshot basically. With the simple linear regression means you have some predictive quantity response variable, and from the basically we can say the qualitative variables, qualitative variable, explanative variable. Both are the qualitative. Polynomial means when you have higher degree polynomials, means you have to find the quadratic fit. Okay, this is the polynomial of n degree. You can say multiple linear regression means you have one response variable and two or more uh, independent variables, you can say. That is the multiple linear regression. Multivariate means you have both are larger, means more than one, you can say. So it may be dependent variable, independent, both will be more than one. Logistic means where you have to find explanatory variables. Okay, 0, 1 type of categorical data you have, and you have to fit the logistic one. Poison, if you have some kind of count data, then it will be perfect. Time series, you have to predict the values. Non-linear means if some non-linear functions are there, like exponential, variable, okay, these kind of uh, figures will be covered under the non-linear. Okay. This is the basic method how the regression works. So first of all, what you have to do, you have to basically formulate the problem. You have to choose a set of variables, choose the choose from the model, choose method of fitting, which method you have to apply. Like generally least square method we have to use to fit the regression line or regression model. So first of all, you have to define the variable, which one is the dependent variable, which is independent variable. You have to identify it. Then you have to fit the model by using some least square method, ordinary least square method, or MPSC, MLE, some other methods are there. Then you have to validate the assumptions. Whatever the assumptions are there, you have to validate them. Means there are residual flows, outlier, sensitivity analysis. Means whatever the assumptions, they are perfectly validate or not. If that is fine, so it will be okay. You can go further. Then evaluate the fitting model. Means whatever the model you have fitted, is that correct? Means there for the one situation or one problem, there are more than one, you can say, fitted model. So which one will be the best? You have to check the goodness of it by using the AIC. You can say AIC, F test, T test by taking their assumptions, or AIC and BIC. AIC means a key information criteria, and this is Bayesian information criteria. Least value of these will be provided the best fitting model. If this is fine, then you can stop. This will be your best fit model. Otherwise, you have to repeat the problem again. This is the flow chart. This is the response variables. Which kind of response variable you can take basically. So dichotomous is can be y means dependent variable. All are dependent variable. Which kind of dependent variable you can take? It can be dichotomous. Either you have to put the value 0, 1 type means predicting the if an email is spam or not. Just you have to put if it is spam it is 0. If not it is 1. The credit card fraud prediction is even is a given credit card transaction is fraud or not. Prediction in health sector prediction if and given mass of issue is malignant or not. Marketing, banking, okay. So it can be the count data like in poison case it will be here. Traffic safety means predicting the number of road accidents per day, per hour, per minute, like this. Health predicting the number of cases reported in that of a particular disease, predicting the number of claims from the insurance company. Okay, so these kind of variables will become becomes dependent variable. It may be the percentage type or proportion type where the limit will be 0 to 1 means proportion will be 100% you can take 0 to 1 you can define these. Okay, percentage. So either it may be survival time. Okay, like health predicting survival time of a patient suffering from a cancer, how much it will survive. It will be survived after 10 up to 10 years, 12 years after getting the disease. Okay, reliability predicting the failure time of a machine. It may be depend like that. If I'm working on, sorry, is anyone saying anything? Okay. So, service you can say predicting waiting time of a customer at a service station. Like you are go to the bank and you have to wait some time. So, how much time you have to wait? So, these can be infinite time. Okay, you can't predict them exactly. So, this kind of variable you can take there. So, the assumptions of linear regression or the ordinary least square method, both are same, you can say. And these are the basically very important. If these are violated, the simple linear regression will not work there. So, what are these? Suppose this is the we have model taken multi multiple linear regression model we have taken here. If you have to find the just two one single or one independent variable, so up to it will be the your model beta naught and beta one x1. Otherwise, up to if you will increase the variable size or parameter size, so it will be the multiple time. So it says that when you have taken the any model or linear regression model and you have to fit the by using the least square method or ordinarily least square method, so it will be follows linearity. Okay, this is the linearity in the parameter, not variable. Okay, zero mean error means whatever the error you have taken, error means this epsilon value. This is normally distributed. Basically, whatever the suppose this is the fitted line we can say, and if you, these are the some data here, you will draw the data. So some values are in terms of normality. So this will be the mean of this value. This is the mean. This is the mean. So we can say that whatever the data we have taken that follows the normal distribution. That's why the error will follow the normal distribution with zero mean and variance sigma square. So basically, whatever the error is there, that having the zero mean, expected value of error term will be zero. Heteroscedasticity means the variance, whatever you have taken sigma square, that will be constant throughout the analysis. Okay. If suppose we are taking x1 value, x2 value, x3 value, so they will not be changed over the simulation or the analysis. If it is same, that will be the heteroscedasticity. Okay, you have to handle that again. So this variance will be constant. Independence means error are uncorrelated across observations. Means whatever the errors you have taken, that will not be related to the their previous values. Okay, that it means like you have 10 observation, 1, 2, 3, 4, 5. Okay, if you, this is the error term here, these error will not be correlated each other. If you are finding the errors or error like x values, and you have to find the correlation between the same values of this variable, that will be called as autocorrelation. Okay, so don't be confused with that. So this autocorrelation will not be there. And the covariance term between x and epsilon value means the variable and error term will not be related to each other. So it will be uncorrelated. So no perfect multicollinearity. Multicollinearity means if you there are linear regression model you have using x, x1, x2 value, x3 variable. Okay, so these values are not should be related to each other. Otherwise, it will consider under the multi-collinearity concept. Due to that, it will impact your study and the variance will increase. And other method to find this variance inflation factor, VIF, this value should be less than 5. If it is less than greater than 5, it means some kind of multipolarity is there. So you have to reduce that, otherwise variance will be infinite type. This is the infinite. Indeterminate form will be there. In that case, the whatever the confidence interval you will create for the parameter beta naught or beta one, that will they will be wide. Okay, so your analysis will be hampered with this. So normality you have already discussed. So first of all, just you have to remember the assumptions will not be violated. These are the graphs we can say here. Uh, these are not clear, but let me explain you. If someone says that this is the fitted line, if one person is saying this is the fitted line, some other can say this may be the fitted line, or some other person can say this may be the fitted line. So which one is the best fitted line here? Which you have to analyze. This is your main purpose in the regression line, or this is the main purpose of the least square method. Least square means you have to minimize the square. What square? Suppose this is the D. Minimize this D square. What is this D? Whatever the values you have taken here, suppose this is this value, this variable you have taken here, and the distance from this value to this line. Okay, suppose this is x1 and y1, and somewhere it will be some value x and y. If you are to find the distance between these, some value is there. So distance is we have defined by d1. Okay, and some other variables are also there. We have to find the distances from the line of each individual points. And these are the D1, D2, and so on. So this is basically sum of BI square. When you will take the square, this should be minimum. This is the basically the property of the central tendency. When you have to take the average of the values, it should be minimum. It will be minimum basically. So this summation d square, that's why we call it as least square method. So for which line this d square is minimum, that will be your best fitted line. I hope so you have understand this. So the same the procedure we have shown here. So this is basically this is the you can say simple linear regression or the OLS method we first discuss here. Then this is the method that simple line method you can say. Okay, linear equation you can say. Beta naught is the slope, beta one is the beta naught is the intercept, and beta one is the slope. Slope means how much is decline from the x-axis. Intercept means where it will meet to the y-axis. This is the intercept. It may be positive or negative, depends on the calculation, whatever the data you have, what you are calculating here. So when you will calculate the ANOVA table, that will also be used to calculate the R square. R square or adjusted R square, that will basically help that any model is predicted well or not. So this is SST, sum of square due to total, sum of square due to regression line, we can say, the intercept term of this. And this is the error term. And this will be basically the residual, or you can say the unexplained part, or this is the explained error. So basically regression line will give you this portion. It means if somewhere r square is suppose 0.08, it means this regression model predict that 80% of the variation, this variation only, 80% of the variation are explained by the variable x that you have taken there. Other, whatever the 20% error are there, they are due to this error term. Okay, by other method, by other factors it may be. But this is the basic funda of this behind this. This will be useful in the next slide. So this I explain this here. So you can I just taken here the generalized method of the ordinary least square method. So basically how it works, suppose this is the line. So is anyone know how to LSE least square method works? If not, then I can explain. Otherwise, we can go further. Let me know, please. Anyone? Okay, in this case, I can understand that you already know, then we can go further. So the variance is by using this equation, basically you are taking the difference between y minus x beta plus minus mu and taking the square of this, and this is taking the summation, or you can define it as error, e, e square, summation of e square. So or just by taking another symbol, you can define it here like s. Okay. So when you have to take, as you have to find the least square value, so maximum by using the maximum minima rule, you have to find the derivative with respect to the parameter. Del s by del beta naught and del s by del beta 1. Okay. When you will get these, you have to put them equals to 0. And by using them, you will get some normal equation. And by if you have two equation, two unknown for the linear equation, simple x and y variable, so it will be two equation, two unknown. So by using solving these normal equation, you can get the estimate of beta naught and beta 1. So these are the method how you will get the variance of the error. Means sum of square due to error, and this is the degree of freedom. Here in this our case, this p equals to 1 because we are taking simple linear regression for one parameter. So p, when you will put 1, so it will be n minus 2 degree of freedom. If you have to test the statistics for any parameter beta naught and beta 1, t statistics you can follow. Means whatever the value you are getting there, it are related to the study or not, then you can apply the t test here. And for that also the degree of freedom will be n minus 2. These are the sum of the square formulas that already discussed. Okay, simple linear regression model. Just as I said, the OLHC and the simple linear regression both are same. So we can see here simple linear regression model. This is the beta naught, beta 1. These are the parameters. This is the independent variable. And this is the error term that follows normal distribution with mean 0 and variance sigma square. Okay, all the things we have mentioned here. No need to explain a bit again. So we have to find, as I tell you, just tell you that by using the LSE method, we can get the estimate, some normal equation. By solving these normal equation, we can get the estimates of the parameter. So beta 1 will be calculated by using this formula, and beta naught, when you will get the beta 1, you have to put beta 1 here. So you will get the estimate of beta naught. Okay, so this is beta 1 again. It is especially nothing but the n summation xy, summation x, summation y, and this is the same formula we can use. This is the just simplification of this one. Okay, nothing else. So R square can be calculated. This is the goodness of it for the regression model that it will be help to explain the model it is well fitted or not. Either you can use this formula or this formula to calculate the values of R square. So basically you have to fit the ANOVA table, analysis of variance. For this, we have taken the example of 10 patients that having the BP problem. So we have to fit the regression model, and we have to find the age is related to the BP or not. Okay. So basically, beta naught intercept here, beta 1 is the slope, and A is the independent variable, and B. So I just told you earlier that you have to define which is dependent variable, which is independent variable. So obviously, age as increases, so BP will also be increasing if some other factors are not involved, like someone is smoking or drinking. Okay, so this kind of model will be you have to define there. So the calculation for this we have taken here 10 observations, age variable x, we have defined this, BP variable y. So in that formula, we have used whatever the values we are required, just we have calculated these here, x, y, x square, and values are there, sum of x, sum of x, y, and the sum of x square. When you will put these value in the formula, you will get the beta 1. This is slope, 1.140. And beta naught you will get by putting the value beta 1 here. So it will after solving 85.0.25. That is the slope of the line. So after that, this is your fitted line. Regression, best fitted model, you can say. Not best, when you have to fit the AIC or something else, then you can say that best. So this is the basically the regression model that interprets here. The slope is this one and intercept is this one. That if we are increasing 1 year in age is associated with the average increase in amount of 1.14 mg in the blood pressure. Okay, this is the meaning of this. So after getting this, these are different values, as you will see here. If you want to find as whatever the values BP they have given, and whatever the estimated or predicted value will be what. So you have to put 35, 40, 38, 40 in place of the age factor here. You will get the estimated value of the Y value. Then you can compare whatever the Y is there and whatever you have estimated. These are related or not. And if they are not related, it means the error term is there. So you can get the estimated minus, total, sorry, observed minus estimated. The error term will be there. That is basically the residual. Or we can say, suppose here. So this is basically y hat value. Okay, and these y values are already there. If you will see, you are putting 35 here, you will get some estimated value that will be y hat, and this is nothing but the error term or residual. So residual, these residuals should be follow normal distribution. Otherwise, your study will be hampered. So based on the other formula, we have just calculated the formula table so that you can get the easily values. And our table we have just created here, source of variation, regression, residual, total. This is the value source of sum of square that we have given already formula. These are the degree of freedom and mean sum of square. Degree of freedom will be sum of square will be divided by degree of freedom. So you will get mean sum of square. F statistics value you will get here by using mean sum of square divided by the mean residual sum of square. And these are the calculated values we have already here. Just put the values here. So we will get the F statistics value. So if this p value is less than 0.5 or 0.5% level of significance, 1% level of significance, or 10% level of significance, so you can indicate that the regression explains a significant portion of the variance in BP. Means they are related. So R square means explained variation to the total variance. Means whatever the variables you have taken there, how much variation they are, their contribution in the variation of the regression model. Okay, how much contribution they have. So basically, this is 8.10 as we have already seen. So 81% of variation in blood pressure rate is explained by the age, we can say. So same thing we have just mentioned here. No need to explain these. These are the R code basically. Don't worry, I will take extra time. I will explain the R code here, and I will take some R class also. So here, this is the age and BP, simple linear regression model, model fitting summary. So LM is the command linear model that used to fit the regression model. And this is the syntax. How you have to write the values. BP is the value, that is the dependent variable that will be right initially. Then this is the symbol curve that defines, that separates two variables. If we are like here are some variables, those are smoking, those are drinking. If these factors are also included, then you have to take plus sign here, plus of these. Then in that case, it will be multiple linear regression model. Okay, but here we are just studying the single one. So it will be the lm command linear model. This is the dependent variable. Curl separates dependent to the independent, and we are the eight independent variable. So when you have to just take this model, it will model fitting summary it will provide to you. But for that you have to get the summary. Write the command summary of this model sample. Means this is something variable you have defined in which your value will be stored of the linear model. When you will get the summary, this kind of result will be there. So when you will see here that these are the estimated value 85, 1.39 something. Okay, these are the standard error. This is the t value, t statistic value means they are getting the enough value or not of the parameter in respect to the parameter. This is the beta naught and this is beta 1 basically. And this is the p value in respect of alpha. You have to compare these, and these are very less as compared to alpha level of significance. So you can say that you have to enough evidence to not reject the hypothesis. In that case, these are the perfect estimates in that analysis. So this is the again the same summary we have defined here. Sorry, ANOVA table. So when you have to use the command ANOVA of this model summary of the regression model, it will directly provide you the analysis of variance table that we have just calculated manually. Okay. So the same value here, degree of freedom 1 and 8, mean sum of the square, F statistics value. This is the P value, where on the basis of this you have to estimate. We have to just rectify this, that this is the best fit or not. So the same after the predicted value, as I shown you that whatever the model you have fitted, you can get the predicted values. So when you will put the age 35 in place of age in that model, it will give you predicted value. And the residual means it will provide you the y minus y hat. Whatever the estimated you have calculated, it will provide you the by this command RESID residual, and this is for prediction. So these are the estimated value. And when you will take the deviation of y column of the table from these value, you will get these residual values. And these residual values already you can get by using command residual. And this is the linear regression model that we have used here. I hope you understand. This is the manual method that we have taken here. This will also provide you the same answer. No need to explain. So now multiple linear regression, as just I discussed here, if you will increase the number of variables and for the linear relationship, that will become under the multiple linear regression model. And suppose these are the, to calculate this, we have just formula as we have taken only here. This is the multiple regression model for the particularly two variables we have taken here, x1 and x2. So in that case, model will be by beta naught intercept, and this is the coefficient of with respect to x1. This is the coefficient of with respect to x2, and u is some error part that we have taken earlier, that is epsilon. So we have just explained here what we have to calculate these coefficients value. And after calculation, you have to formula beta 1 and beta naught, means after solving the normal equations, after applying the least square method, you can get the these coefficient values. So basically, this is the example we have taken here. This is a study considered involving 10 students of investigating the relationship and effect of revision of time and lecture attendance. Means you have to examine the examination scores that we have given here, y, dependent variable. Is there any effect of revision on the course or those have attended the class? Both variables we have taken, is there, they are effective to get the higher score in the exam. So this is the problem. Same formula we have just applied here, means whatever the formulas are required to calculate this function, we have just calculated here by using either you can use Excel or just some other method. It will be easy, or just make the table to paste in. So these are the calculations. So from after calculation, beta 1 and beta naught and beta 1. These are the coefficients 65, 0.65, 1.11, and intercept is 31.9 each. So this is your, in this case, this will be your best fitted line. Okay, when you will put the value of x, okay, so we can say this is the part that you can explain, and that is defined by r square, means whatever the responses or changes are coming, that is r square, explained variance we can say. And this is the unexplained variance, error term may be there. So these are the unexplained variance. So when you will put the value of x2 here, it will be provide you the estimated values. This is the ANOVA table, same method we have applied here. Adjusted R square is another method, another value that you can use by using this formula. And sometime it happens that R square is overfitted, so it will be adjusted by the adjusted R square. So you can explain whatever the variation is there due to this, it will be explained by R square. This is the multiple linear regression model. R values already defined. This is exercise for you. You can take this. And as I told you, after fitting the model, you have to find which one, if you have fitted two or three models, like by taking two or three variables. In one model, you have taken five variables. In one model, you have taken four variables. Means you have removed some variables. Those are less important. So which one will give you the best fitting model? You have to calculate the AIC value. Least value of AIC will provide you the best fit, goodness of it. AIC or BIC. Stepwise selection means if some variables are multi-collinearity are there. So you can remove some variables by using the step regression method. Okay. So this is not the part of this one now. Okay. So up to here, now we have to go to the R window. Is it visible to you all, R screen?
Yes, sir.
Uh, if I have time, 10 to 20 minutes.
हाँ सर, हाँ सर.
So the same example I have just used here, and these screenshot I just pasted in the PPT. So don't be confused with that. So the same example, first example for correlation, I will just show you. This is the statistics scores and science score. Okay, X and Y, you can take this one or just by taking their name. So this is just select this one, run the command, control enter you can press, or just run this one. This is the run. Whatever the command you want to run, just select that one and run, paste or click on the run. So whatever the output you can see in the lower part of this R scroll window. So if you want to take this, you want to define in terms of tabular form. So you can use the command data frame, statistics, science, some other variables if are there, you can add them here. So this is run again. If you want to see the data, run the command D1. So it will provide you in terms of data frame. Okay, tabular form. So first of all, you want to find the correlation coefficient Pearson. So this is the command COR. You want to find between the statistics and science method Pearson we have defined here. Just press here, enter, or control enter, either press on run. So it will be give you the results. Then Pearson test. All the values you will see here. This is the correlation coefficient that we have seen, the same value here. The Pearson test value, this will provide you the test statistics and p value. If you are taking 1%, 10% level of significance or 1% or 5%, on that basis you can identify this one. Okay. If you want to plot either scatter plot, you want to plot this one. So you will see this is the scatter plot. Okay. If you are using the regression line, regression fitting, so you can just fit the line. Then Spearman, then correlation coefficient. The correlation again command here is Spearman core test, Spearman raw correlation coefficient. That is 7090. The same value we got the in example as I shown to you. Next is candle. We have not taken here in the PPT, so just skip this one. If you want to do the same method by manually, so you have to just find the length, how many numbers or students are there. That is length equals to 10 you have taken, and just either you can directly write here 10. Okay. Or if the number is larger, just take the length. You have to calculate x bar, sum of the square due to x square, sum of the square due to y square, y, and this is xy, sum of xy square. Or manually, this is the covariance of x square and variance of x and y, square root of this. Then you can paste the results. These are the same results as I pasted in the PPT. If you are using another method, then you can use this command. Okay. This for partial correlation that we have not included here. So for the regression one, we can see for single and multiple both regression we have taken here. This is the regression command. First of all, whatever the example you have taken, you have to define which is the dependent variable, which one is the independent variable. So age is the independent variable, BP is the dependent variable. So run the first, store the command in the age vector and BP vector. So whenever you will call this age, it will show you the values. When you will call this BP vector, it will show you the values that are stored in this. For multiple correlation, just directly run this command. It will be stored here. So for the linear model, for the BP one, you can run this command here. Model specification. When you will see the model sample, it will give you this is the formula, LM formula you have taken, and BP is the dependent, age is the independent variable here. And these are the coefficient. Coefficient means this is the beta naught and this is beta 1 we have taken. And if you want to separately see the coefficient, just use the command coef coefficient for and just run the command. It will show you separately. Then if you want to plot this one, plot ab line fixed. Just hold a second. Some problem is there. Just hold it. Select all and then the command. Somewhere in there, I think some length issue is defining. Okay, but graph will be there. In other example, I will show you. So for the coefficient, if you want to see the summary here, this is the summary of select whatever the command you want to run, just select that one only. Run this command. It will provide you the whole summary. Means minimum, maximum, median, first quartile, second quartile. These are the coefficient and their standard error, estimated values. Okay, here it will provide you the residual values or degree with degree of freedom multiple R square. This is basically R square value 0.81. Okay, that we have calculated. Adjusted R square 0.78. F statistics value this one with degree of freedom 1 and 8, and P value is 0. This one. So we can say that P value will be less from alpha level of significance, 5% of level of significance. So this is well fitted model and explained by that is affecting the BP. Okay, as increasing the age, BP will also be increased. So for the ANOVA table, just use the command ANOVA model sample. Okay, print this same result it will provide you ANOVA table. If you want to do by the manual method, either you have to use this one. So this one is residual. You can calculate the residual samples. This one predicted values as I shown there. This is the predicted one. You can see the results here. So if manual method you want to follow, that you can use directly whatever the formula is there, just write here and it will provide you the answers. Okay, cat is used to print all the values by using some spaces. Okay, some space are there separately. For multiple linear regression model, you can see here, this is the name we have defined where I want to save this model. Using the command, same command we will use here ln, y is the dependent variable, x1 and x2 are the independent variables. So by using plus sign, you can add more independent variable here. So just first take the run command here, print coefficient, it will provide you, print predicted values, print residuals. Now see the predicted values and residual values. Sorry. These are the sum of square by manual method. Adjusted R square 0.98 as we have seen. Okay. So these are the further calculation for higher model. If you are having some multicollinearity or variance inflation factor, you have to calculate. Some commands are there. So no need of these to run here. See this one as well. This is that is the data that I have stored here. Okay, I just inserted from the Excel or somewhere. This is the cars data. If you want to use some data that is already having the R window or in the R package, you can use them also by using the library in which some data set already there. Okay, so this is the command where you can access by using this. You can access the whatever the data is stored in this data set variable name. Okay. So this is data basically related to the cars. Okay. And if you want to see the data, add command use some higher values, speed and distance means you want to find the relationship there. Is there any relationship while you are increasing the speed? What is the effect on the distance? Okay. If you want to the whole data, just run the command cars. This is the whole data. 50 values are there. If you want to clone this data, some issues are there. Yes. Mm, just hold a second. Okay, you can see the plot here. So this is for car, the speed data, distance means dependent, distance is the, you can say the dependent variable, the speed will be independent variable, and you have to mention the data that is cars. Okay, just run the model here. It will provide you the intercept and slope. This is beta naught and this is beta 1. These are the coefficients. This is the parameter. This command is used when you have to see more than one graph in single window. So parameter mf row, we have just reused here plot. Again, it's showing the same error. Add line. Okay. Some error is there, I think. But the method as you see earlier, the plot will become in this way. Okay. Line command is used when you have to put a line on the data, the line, regression line. So this command will be used there. Somehow it is not getting here. Okay. So this is the fitted values you can see. Okay, this is the residual versus fitted values. Means whatever the fitted values are there and whatever the residual values you will see in this graph. Okay. Next, if you will run this again, you will get QQ plot. Means whatever the error terms are there, they are basically provide you the normality or not. You will see here 35, 23, 49. These are the outliers. Somewhere normality is not showing there. If you will run this again, this is the scale location. Means some outliers are there. You can find these by using this method. Residual versus leverage, some points are there. Those are affecting your study. Then you can use by using this plot. Fitting values, if you want to see, this is use command predicted cast. All the command are that we have used here earlier, that will be same. Okay, just the method I just want to show here. It means whatever the command you are using, they will be same for either you have taken the data from here or somewhere else. Thank you for everyone. Is any question there for me?
Thank you so much, sir. Participants, if you have any query, you can ask now.